So this standard deals with taking all the chemical reactions that exist in the world and putting them into different groups according to kind of what they do. That's impossible for every single reaction, but the majority of them will fit into one of five categories. So that's what we're on now. So these are the types of chemical reactions that occur. Again, there's um, combustion, which means burning. This is specifically referring to the burning of hydrocarbons, carbon and hydrogen compounds. Then there's synthesis, where two elements or pieces come together to make one thing, one final product. Decomposition, this is where you take one thing and take it apart into pieces. You decompose it. Then there's single replacement, also called single displacement, reactions where you have a compound and another element comes in and kicks out one of the elements and takes its place. And the fifth kind is double replacement, where two compounds actually trade parts. So we'll look individually at each one. Combustion is when a compound made out of carbon and hydrogen is burned. Of course, anytime you burn, you need oxygen. And this type of reaction is unique to combustion because it always gives you the same two compounds as a product, always. And that is carbon dioxide and water. So predicting these reactions is kind of easy because you just predict carbon dioxide and water. You just have to recognize that it's a combustion reaction and then you already know the products. So it's always going to look something like this, where you have some kind of a compound plus oxygen makes carbon dioxide and water. The only thing that's going to change is the compound itself. Now, it may say water and carbon dioxide, but they're both going to be there. So here's an example of what that would look like. Okay, the next kind is synthesis. In synthesis means to create. So you're creating a new product. So this is where you bring two or more, usually elements, but they can be anything. Like they could be compounds where you're making a bigger compound. But two things come together to make one big whole thing. So it's going to look something like this. The A plus B, again, they could have subscripts, they could be compounds, but the point here is the easiest way to recognize this one is that there's only one thing to the right of the arrow, only one product. So here's a true life example where you're taking hydrogen and oxygen and putting it together to make water. This next kind is called decomposition, and it's kind of the opposite of synthesis. It's when you take a compound and you take it apart into pieces. So you only have one thing on the left side of the arrow this time because it's breaking apart. And decompose means break down. So it's going to have one thing on the left and then the arrow and then pieces. So the true life example would be taking calcium carbonate apart into calcium oxide and CO2. This kind is called single replacement, and this is where you have an element that comes in, breaks the bond in a compound, and it inserts itself in place of one of the elements. Which element totally depends on what its charge is. So the single element, what charge it would be, where it would replace. So it's going to look something like this. A comes in, it's a single element, it's going to break the bond between B and C. If A is positive, it's going to look exactly like it's written there, as in A joins to C and kicks B out. If A is negative, then your products would be Ba plus C. So it kicks out whatever's charge is like its own. And here's a real life example. This is double replacement. In double replacement, you have two compounds, and you know the positive always comes first and the negative always comes second as far as within a compound. So then they just trade. So they might trade native ions. So if we had a compound AB, A is the positive and B is the negative, and then CD, C is the positive and D is the negative. So you take the back end, the B and the D off, and you switch them places. So that would be a double replacement. The easiest way to tell these is that everything in there is a compound. Everything. So real life example, and this has polyatomic, so it's real easy to tell. But again, make sure everything is a compound, because combustion, everything's a compound except oxygen. So you just kind of got to watch for that one. And that's the 5 types. Now let's practice some. Okay, practice. Figure out which kind this is. So it's got 2 elements on the left, 1 product on the right, 1 compound. So 1 product on the right means you're building something, so that's synthesis. Next one, NaCl is a compound, F2 is an element, NaF is a compound, Cl2 is an element. This is a single replacement. Single replacements I always know because it's an element and a compound on each side. Next one, you got 1 thing on the reactant side, on the left side. So that's got to be a decomposition.